In this video today, we are going to learn how to differentiate using the power rule. Now, what is the power rule? The power rule says if I want to find the derivative, so d over dx, of x raised to a certain power, well, that is going to be equal to the power multiplied by that same x, but now with the power to the minus 1. So the derivative of x to the n is equal to n times x to the n minus 1. Now this is symbolic. You can represent this symbolically as, for example, the n hopping forward and leaving 1 behind. So let's work on an example. Suppose I have x squared and I want to differentiate x squared. Well, the first thing we're going to do is we're going to find our n and our x. So obviously our x is just equal to x, but then the n here, n is equal to 2. Now we plug these values into this equation right here. So we get that n is 2, so 2 multiplied by x to the n minus 1. So n is 2, n minus 1 is 1. So we get 2x to the first power, and this right here is simply equal to 2x. So our derivative for x squared is 2x. Now again, I can do this a bit simpler by using the quote-unquote symbolic method. So let's say I still need to differentiate x squared. Well, what I can do is I can hop the 2 forward and then subtract 1. So that's going to be 2x, and then 2 minus 1 is going to be 1. So again, our derivative is 2x. Now let's work on a few difficult problems, let's say. So just to train our brains. Alright, so now let's differentiate x cubed. Now again, same process here. I'm going to go in with x cubed, and I'm going to bring the 3 to the front and leave minus 1 behind. So 3 going to the front, that's going to give us 3x, and then 3 minus 1 is 2. So the derivative of x cubed is going to be 3x squared. Now here's a problem to try on your own. What is the derivative of 3x squared? Go ahead and try that one for yourself. Now, this involves a bit of a deviation to our original equation, but the principle stays the same. What we do here is we hop the 2 down, but instead of just keeping the 2 there, we multiply it with this coefficient in the front. So the formal formula for this is the derivative of a times x to the n is equal to a times n to the x to the n minus 1. So the only key part, the only thing we're changing here is we're multiplying that n by that coefficient. So in our example here, what I'm going to do is I hop the 2 down. So let's say I have 3x squared. All right, I hop the 2 down and I leave minus 1. Now here's the thing. So we have 3 times 2 hops down, 3 times 2, 2 times x, and then 2 minus 1 is 1. And simplifying this first part, we get 6x to the first, which is equal to 6x. So the derivative of 3x squared is simply 6x. Alright, now let's incorporate the sum rule. If you want to try this on your own, feel free to go ahead. So our problem is, let's find the derivative of 4x cubed plus 2x squared plus x. Alright, so now the sum rule says that whenever we have an addition, we simply basically distribute. It's not distribute, but we take this derivative to all three terms. So for example, this is going to be the derivative of 4x cubed plus, alright, the derivative of 2x. Let me write that in a different color. 2x plus the derivative of x. Alright, that's basically what the sum rule says. So now, let's peel through this one layer at a time. First, let's find the derivative of 4x cubed. Remember what we said here? We just hop the 3 down and multiply it with this 4 while we're at it. So we're going to get 4 times 3 times x. Alright, now this leaves 1 away. So we get 3x squared. 4 times 3 is 12. So we get 12x squared for the first derivative here. Now let's move on to this part. The derivative of 2x. Okay? Actually, sorry, 2x squared. I forgot to put that there. Alright, same thing. We're going to do the same exact thing. We hop the 2 down, forward, multiply with this bottom 2, and this leaves away 1. So we're going to get 2 times x, and then 2 minus 1 is 1. So 2 times 2 is 4. So we get 4x to the first, which is equal to 4x. Now, what is the derivative of x? What is the derivative of x? Let's try the same thing. So there's an invisible 1 over here, right? So we hop the 1 down, and then we subtract 1. So we get 1x to the 0th power. Anything to the 0th power is simply equal to 1. So this expression is the same thing as 1 times 1, which is, again, 1. So the derivative of x is simply equal to 1. So we get 1. Alright? Now let's clean up a bit here. So these are our three derivatives, right? And according to the sum rule, we are going to add them together. Plus. So our final answer is going to be, okay, so let me rewrite everything again. This is going to be equal to 12x squared plus 4x plus 1. That is going to be our final derivative. So here's a really important topic that you need to know. Let's say, for example, I am differentiating 3 over x cubed. Alright, now how am I going to differentiate this? The x is on the bottom here. So how will I go about approaching this? Well, we can actually turn this exponent into a negative exponent. So this becomes the derivative of, so we raise this up here. So this is going to be the derivative of 3x to the negative third power. Okay, so these two are the same thing. The only difference is I took this x cubed from the denominator to the numerator. So I'm going to get 3x to the negative third power. Now, you guessed it, same thing. Hop the exponent to the bottom, leave away 1. Alright, so we're going to get 3 times negative 3 is hopping on the bottom, so 3 times negative 3 times x, and negative 3 minus 1 is negative 4. So let's combine like terms. Actually, well, there aren't any like terms, but let's simplify everything together. So 3 times negative 3 is negative 9. And then this is simply x to the negative 4th. Okay, if you want to make it a bit prettier, you can make the exponent positive by bringing this down again. So this is going to be the same thing as negative 9 over x to the 4th power. And that is our derivative. So that's how you handle negative exponents. You just simply make them positive by bringing them up or dragging them down, and then you differentiate as normal. So here's a challenge for you guys to test your skills, okay? So I'm going to make a problem. So we're going to differentiate, all right? So we're going to differentiate the following problem. We're going to differentiate negative 4 x to the negative 7th plus 3x to the 4th plus 2x to the 3rd plus x. All right, now it's a daunting problem. It looks daunting, but remember, it's just the sum rule here and the product rule. So again, we're quote unquote distributing this dx to wherever there's a term right here. And I will talk about this rule in some of my future videos, but essentially what we're going to do is this is the same thing as the derivative of negative 4x to the negative 7th, right, plus the derivative of 3x to the 4th plus the derivative, of course with some disrespect to x, the derivative of 2x cubed, and finally plus the derivative of x. I'm just going to leave it as x here because I don't have any space, but imagine there's an invisible d over dx here, d over dx. All right, let's peel through this one by one. So here's what we're going to do. Let us use the power rule again here. So negative 7 drops down, leaving 1 minus 1 behind. Again, if you want to pause the video and try to solve this for yourself, please feel free to do that. So this is going to be the same thing as negative 4 times negative 7. All right, negative 4 times negative 7 x to the, so negative 7 minus 8 is negative 8. All right, negative 8th power. This simplifies down to, so negative 4 times negative 7 is 28, x to the negative 8th power. All right, we're going to add it with, so let's find the derivative of 3x to the 4th. So again, 4 hops down minus 1. So we are going to get 3 times 4x, and then 4 minus 1 is 3, right? 3 times 4 is 12. 12x cubed is going to be our derivative for that second equation, or sorry, expression. And of course, we add 2x cubed, derivative of 2x cubed. 3 hops down, minus 1. So we're going to get 3 times, sorry, we shall get 3 times 2x, and then 3 minus 1 is again 2. So the derivative here, so 2 times 3 is going to be 6. 6x squared is going to be our derivative. And again, do you guys remember what the derivative x is? Well, if we use the power rule, if you want to check, you can. This is simply just going to be 1, so plus 1. And now that we have all of our parts, let's simplify and make it look a lot neater. Well, not simplify, just make it look neater. Right, wonderful. So let's rewrite this. So we get 28x to the negative 8th plus 12x cubed plus 6x squared plus 1. And that is going to be our derivative for this following expression. I hope you guys enjoyed this video. If you need some other help with calculus, I will be posting more videos on product rule, chain rule, and quotient rule, and I'll see you guys in the next video.